This is our project where we start from the next part. So first of all, we create a data injection part where we collect data from the data source. That is in my data folder, which is in this part. And after that, what we have to do, we have a src for exceptions, and we import the log for our logging system, and we select the model for the we split the data into train and test. And after we import the data classes, this data is used to create a abstract class, or you can define the data types of using a class. So we have used the decorator of data class in the data injection config, so where we create a data type of this data inside config without using in it. Then we start the data injection part. First of all, what we have to do, we have create path, that is data injection config, that is our train test and our original data we store. And we have to do, then we read the data from the notebook, that is test split. And after that, that is our data. And what we have to do, we have a src component, and in component we have data injection. So we have control x. Okay, now our data is clean and clear. So first of all, we read the data from data file. After read, we have split the data into train and test. After splitting the data into train set and the test set, we have written our, when we call this function, we return our the self config train path and test path. When we use this, we call the function train test data as a variable when call the object of initiate. After initiating, what we have to do, we have go for data transformation. In the data transformation, what we have to do, we import the data from train dataset and test data. There are some import, that is numpy, pandas, and data class for the file, and the logger using the compose. Compose is basically used for the column transformers. Column transformers basically work on the all column at every time. So this, so what we have to do now, that is our compose impute, the simple imputer. That means it is used for fill the any null values with the mean, median, mode, or any mathematical function which is beneficial or frequency, whatever we want, we use from the simple impute. And then we create a pipeline, that is a pipeline class which is used to run our another pipeline in this project. So in pre-processing, we one hot encoder, that is a change our categorical variable into the numerical variable into 0 and the ones, and the standard scalar, that means we convert our value into the range of 0 1. And then we create a class which is a transform data. First of all, we call the path data transform config, then where we use to store our artifacts folder in pre-process pickle. Pickle is nothing but it is a file to store our pre-process data. So that is, we try catch use the first of all, we choose the numerical columns, read, write, and then we choose the categorical columns. That is, after that, we don't use here for the math score, because math score is our y score, means test data. That is our output data. So that is create a numerical pipelines where we use impute as a median in simple imputer, and we scale with the standard scaler. Before that, use for critical data, that is most frequent data, means we critical data this most frequency means it is not represented in the numbers but the count is presented in the frequency. So we use here most frequent one hot rate code are changed. And then we write in logging information we have completed. After that we pre-process every column with this. So what we have to do, we do num pipeline with the num pipeline which is used into data transformation. First part we transform data but we convert into numerical columns, that is our num pipeline, that is, and numerical columns. And categorical pipeline get impute get pipeline and change into categorical columns. After that we run the preprocessor. So where we define the preprocessor, we define here, or then rise, that is preprocessor column transformers. After that we have initiate data transformation where we exactly load our data train path and test path. In here we read the train data and test data, we logging, then we preprocess our object. So we call from the self dot get data transformer object, that because this is the same class function. So after that we choose the target column, that is math score, and after that we read the numerical column, and then we create a train data set, that is drop our math score, and we again target feature train where we use our train column name because this is our target, that is why that is math score. And again we create for test data set, and we again target data set for the test, which is target column name, that is math score. After that we write the logging information to track our program. And after that what we do, we have fit transform our data. So input of input data train, then preprocess object of transform data of input feature test data. After that train array, that is C. What we have to do with C? So here we use that when we use np.c, that is create a column of input feature train array and the array of train feature train, means basically we create a in a single data frame of the data of input feature train or target features, means x, that is a x value and that is a y value, and we all create in a array form. Again this we do for the test array, we again np.c underscore, which is create a array of input feature test array and the np array of target feature. So that we save the object. So for saving we create a save object function which is in our utility functions. So what is in this utility function, I will show you the save object function. In this we do logging, start the object save, and we create a path directory name which is basically pass in the path, and the object in the object we have what we have to do, we read in binary or as a file object, or we use the pickle. Pickle is nothing, is a python package to store any data set in a pickle form, or dil, which will store one by one. So that is our dump object on the file object name, dump on dump the object on the file object. So basically this is done in this part. So after that we save this file path and object, we return from this all function, that is train array on test array, and self dot data transform config dot preprocess object file path. With three things we return from the function data initiate. So where we see this three function are given back, that is here basically train array, test array, data transform dot initiate data transformation, train date and test. Here we give back train array and test array because we convert these all into array, and this is our path. After that, what we have to do, we create our model. So model is nothing, we just create a list of models and list of parameters of the models, and one by one pass and run. So first of all, these are some linear regression model, that is scatter booster regression, ada boost regression, gradient boost, random forest, and linear regression simplest one, and R2 score, that is a matrix accuracy score for linear regressions, k neighbors regression, decision tree, and XGBoost regression. Custom exception we know very well, and we use utils file from the sab object and the evaluate matrix model. So we have again see you the evaluation models. So basically this is a function which is used to convert, which is used to take as a parameter of train x train, y train, x test, y test, and the model name and the parameters. It's pass here, and what we have to do, we use one by one, and we have give the name, model, and parameters, and we use grid search cross validation of the model and the parameters pass in the grid search cross validation with the cross validation of 3, and we go for the fit x train, y train. After parameter dot set params dot args, we set. After that model dot fit, we here in the model we y train predict or y test predict, that is two input, or that is our real value of prediction, and give we return the R2 score from the y train or y test. So that is our final output, that is. So after that, what we have to do, we again go for data model trainer, we create, we split the data into train array and test array, we define the model name with the model's class name. After that, we define the parameters. In the parameters, after that, we have to do, we create a model report, that is a dictionary type, and in dictionary type we use a pass a function, that is evaluate models, which is so before this. In utilities, we pass one by one, and there from it give me report a model report, and we get a value from this model report. And what we have to do with this, we get one key, and we see the best model, which model is best. For choosing the best model, we choose the criteria 0.6, that is our criteria. After that, we save the object in the file, that is self.modeltrainconfig, which is our configure file path we give, and the object best model. The best model is our model name. And predicted best model dot predict, we use best model to predict our x test value, and we use again the r square value and return the r square value as a result of accuracy. So this is our final answer from this whole machine learning project. So this is our whole machine learning project. After that, we have, what we have to do, we create a Django Flask file to visualize our data.